Hi everyone, welcome to Learn Engineering with Mira. Today we will solve a problem on a gantry crane truss using method of section. It is a quick method to find out forces acting on some particular members of truss. So let's see the problem statement. This is a construction site of a factory where number of truss gantry cranes are used to lift and handle different heavy units. A gantry crane is an overhead crane generally useful for outdoor applications. They are movable as they are mounted on wheels, and here truss cranes are used so they can lift heavy loads with minimum self weight. So let's take the front view of one of the plane truss of this crane and find out forces acting on some of the members. The crane is supported by a hinge support and a roller support at joints A and B respectively. Suppose length of all horizontal members and height of this member is 6 meter and this height is 22 meter. Lifting of the beam imposes 1000 kN force in downward direction at joint G. Then find out the forces acting in members CD and EF. The first step in this method is to find out support reactions. Here at joint A, there is a hinge support, so there will be two reactions, RA in vertical direction and HA in horizontal direction. At joint B, there is a roller support which restricts only vertical movement, so there will be only one reaction RB. Let's see the sign conventions we are going to use. Upward force will have a positive sign and force acting in downward direction will have a negative sign. Similarly, anti-clockwise moment will be positive while clockwise moment will be negative. Now consider the free body diagram of the truss as a whole. For this, consider only the external forces and reactions and ignore the forces acting on members. Now there are three equilibrium equations available to find out reactions. First equation is summation of horizontal forces is 0. So H is equals to 0 because there is no other horizontal force acting on the truss. Now sigma Fv is equals to 0. Forces in upward directions will be positive. So Ra plus Rb. And the external force of 1000 kN will be negative. And this is equals to 0. We don't know the value of Ra or Rb yet. So move to the next condition, that is sigma ma is equals to 0. We know that moment is force multiplied by distance. Suppose joint A is fixed and only Rb is applied. It will rotate the truss in anti-clockwise direction, so we'll have a positive sign. There are four horizontal members in between reaction Rb and joint A, and each of them is 6 meter long. So distance of Rb from joint A is 6 into 4 is equals to 24 meter. So moment is Rb into 24. But if only 1000 kN force is acting at G, truss will rotate in clockwise direction, so it will have negative sign and its distance from A is 6 into 3 is equals to 18 meter and summation of both moments is equals to 0. So we get Rb equals to 750 kilonewton. Put this value in above equation and we get Ra equals to 250 kilonewton. Next step is to cut the truss into two separate parts by a section line. This section should pass through maximum 3 members with unknown forces. If no particular member is given in question, you can select any subsequent 3 members even if they are not parallel to each other. But here, as it is asked to find out forces in members CD and EF, the section line must pass through these 3 members so that truss will be divided into 2 parts. Next we have to locate forces at all the cut members, assuming that these are the internal forces acting in members. The force can either be tensile or compressive. Let's assume that all the forces are tensile. Name the forces like FCD, FEF, etc. nearest joint first and then joint at other end of member. Now select any of these two parts of truss for analysis. Result will be same for both parts, but to make the calculations less complicated, and try to select smaller part with less number of external forces. So let's select the left part for further analysis. So now find out all the unknown forces by using equilibrium equations. But before that, if any of the selected 3 members are inclined, find out the angle they make with x or y axis. Here DE is an inclined member and let's say it makes theta angle to x axis. Now in right angle triangle DEF, the length of opposite side and adjacent side is given, that is 6 meter. So use equation of tan theta and we get theta equals to 45 degree. Now let's get back to the force analysis. We know that we have 3 equilibrium conditions. First we will solve for the condition sigma m is equals to 0. Now to select the joint about which the moment is taken, out of the 3 unknown forces, select a joint where at least 2 of them are meeting. Here at joint E, line of action of 2 unknown forces FED and FEF are meeting. So if we take moment about joint E, moment of these 2 forces will be 0 and now we will have to worry about unknown force FCD and reaction, that is 250 kilonewton force only. Now let's think that joint E is fixed and only FCD is applied. It will rotate the truss in clockwise direction. So it will have a negative sign. Also the distance between joint E and force FCD is 6 meter. So moment will be minus FCD into 6. Similarly, 250 kilonewton force rotate the truss in clockwise direction too. And so it will also have negative sign and its distance from E is 6 meter. So moment will be minus 250 into 6 and summation of both moments is 0. So FCD is equals to minus 250 kilonewton. Next condition is sigma FH is equals to 0. So let's first write the components of inclined force FED. We calculated that the angle member ED make with x-axis is 45 degree. The components will be FED cos 45 and FED sin 45 along x and y axis respectively. Now these are the forces acting in horizontal direction. So let's add them up because they are in same direction. There are two unknown forces in this equation. So let's move to the next condition. Sigma Fv is equals to 0. And so FED sine 45 plus 250 is equals to 0. And FED is equals to minus 353.55 kilonewton. Put this value in above equation and we get FEF is equals to 500 kilonewton. In problem statement, it is asked to find forces in members CD and EF. So the force in CD is FCD, that is minus 250 kilonewton. Now as we have assumed that the direction of all the forces is tension, negative value here indicates compression. So simply remove the negative sign and write compression or C instead. Similarly, force in member EF is 500 kilonewton, which is positive. So assume direction tension is correct.